Welcome back everyone. Today's video will be about exponential equation. This is also called solving equations with unknown value in the index. Once you have an equation and the bases are the same, then you can equate the powers. So using this fact, we can find an unknown in the exponent or the power. For the first example, we want to solve this exponential equation here. So we realize that we have an unknown in the power. So remember that the fact says that when a to the m is equal to a to the n, then we can say that m is equal to n. So we realize that the base is the same. Therefore, we can equate the powers. So x plus 2 is equal to 5. And from here, you're going to solve for x. We have a 2 adding itself to the x. So the opposite operation of addition is subtraction. So to get rid of this plus 2, you need to subtract 2. And we know that what we do on one side of an equation, we have to do it on the other side. If we subtract 2 over here, we have to subtract 2 on the right-hand side. So positive 2 minus 2 gives us 0. So we're left with x on the left-hand side, and 5 minus 2 is equal to positive 3. The second example, we want to solve. So we realize that the bases are the same. So both of the bases are 3. So we can go ahead, therefore, and equate the powers. 5x is equal to 4x minus 2. So I want to get rid of this positive for x. So the opposite operation of a positive is minus, so we're going to subtract 4. So let's write this back. So 5x, if we subtract 4 on the right-hand side, we have to subtract 4 on the left hand. 4x minus 4x, and we write back the 2. So we know that 4x minus 4x will give us 0. So we'll have negative 2, and 5x minus 4x gives us x. Now the third example, we realize that the bases are different. The fact states that the bases have to be the same for us to equate the powers. Therefore, we need to get both bases to be the same. How can we get both bases to be the same? Can we reverse this 128 so that we have the base to be 2 raised to a power? Yes, we can. So we know that 2 to the 7th power is 128. So we reverse the 128 and write it as 2 to the 7th power, which is the same thing. So we now have both bases being the same. And we know that once we have both bases being the same, then we can equate the powers. So 3x is equal to 7. And all you're doing right here is solving for x. So we have a 3 multiplying by the x. So the opposite operation of multiplication is division. So we need to divide by 3. And what we do on one side of the equation, we have to do it on the other side. So 3 into 3 goes 1 times. 1 times x is x, and we are left with 7 over 3, or this can be simplified to 2 and 1/3, or a decimal. Here's another example. So let's try to get both bases to be the same before trying to find the unknown. So we realize that this is a 4 here. So we know that 4 cube gives us 64. So we can rewrite this 64 as 4 cubed. We write back our initial powers, and we write back the term that was on the right-hand side. Now, we realize that we have a power raised to another power. From the law of indices video, we know that when a power is raised to another power, we multiply. So let's do that multiplication over here quickly. And in bracket, we have 3p minus 2. So we know that we multiply the term outside by the terms inside of the bracket. So 3 times 3p will give us 9p. And 3 times negative 2 will give us negative 6. So we can rewrite this as 4 raised to 9p minus 6. This is equal to 4 to So 2p minus 5. So we have gotten both bases to be the same, and we have simplified the power so that we only have one power on each side and one base on each side. So therefore, we can go ahead and equate the powers. The 9p minus 6 is equal to 2p minus 5. Let us now find the value for p by first getting both of the unknowns on one side. Let us get rid of this positive 2p. The opposite operation is subtraction, so we subtract 2p. All we do on one side, we do it on the other side. So this will give us 0, so we're left with negative 5 on the right-hand side. 9p minus 2p, that is 7p minus 6. We want to get rid of this 6 that is subtracting from the 7p. So we need to add 6 on both sides. So we're left with 7p equal to positive 1. And to get rid of the 7 multiplying by the p, we simply divide by 7. Therefore, so p is equal to 1 over 7. Question number 4. First things first, we need to get all of the bases being the same. So we can rewrite this 36 to have the base 6. We know that 6 squared is 36. And we just rewrite the rest of the equation. So now that we have gotten all of the bases to be 6, let us simplify using the laws of indices. We have two terms with the same bases being multiplied. We add the power. So the power for this 6 would be 1. So it would be 1 plus 5x. And for this side, it would be 2 plus x minus 7. And we can further simplify this to give us x minus 5. So we have the bases being the same, so we can equate the powers. So 1 plus 5x is equal to x minus 5, and we solve for x. So let's get rid of this positive x by subtracting x on both sides. So we'll have 1 plus 4x equal to negative 5. We want to get rid of this plus 1. So we subtract 1 on both sides, and we'll have 4x is equal to negative 6. We need to get rid of this 4 multiplying by the x, so we divide. So 4x divided by 4, and what we do on one side, we do it on the other side. So therefore, x is equal to negative 6 over 4, or negative 1.5. Now these questions are a little bit different. We realize that one of the terms is a fraction. Now it's the same concept. We need to get both bases to be the same, but first we need to reverse this fraction. Now from one of the laws, we know that if we have a negative in the index, then we can get rid of the negative index by reciprocating the term. So we can reverse this by writing this as a negative index. This can be written as 64 to the negative 1, and we rewrite the term on the left-hand side. So now that we have gotten both terms as a whole number, we realize that the bases are not the same. So we need to write the 64 with the base 8. We know that 8 squared is equal to 64, so we can rewrite it as 8 squared. And we have a power raised to another power, so we multiply. So this would be 8 to the negative square. We write back the left-hand side. So we have both bases being the same. So therefore, we can equate the powers. So we have 2x equal to negative 2. We want to solve for x. So we need to get rid of this 2 multiplying by the x by dividing by 2. So x is equal to negative 1. Same concept with this one. So let's start by first reversing this fraction. So we can rewrite this as 443 to the negative 1. Now we need to find a base, common base, that we can write both of these terms in. So 7 squared gives us 49. And we know that 7 cubed gives us 343. So we have rewritten both terms with the same base. Let us simplify. Power raised to another power, so we multiply. So 2 times 3x would give us 6x is equal to 3 times negative 1 is negative 3. Therefore, 6x is equal to negative 3. Let's solve for x. So we divide both sides by 6. X is equal to negative 3 over 6, or negative a half. Our final question. So the smallest base is 3. So let's try to see if we can rewrite 9 and 27 with the base 3. This bracket means that they are being multiplied. Square gives us 9. We write back the original power. And we know that 3 cubed gives us 27. So we have the bases being 3. Let us simplify the powers. So we cannot go ahead and equate the powers because the left-hand side over here is not simplified. Right? So we have two terms, same base being multiplied, so we can add the powers. So when we add the powers, 2x plus 2x gives us 4x because they are like terms, minus 2 is equal to 3 cubed. So now we can go ahead and equate the powers. So 4x minus 2 is equal to 3. We get rid of this minus 2 by adding 2 on both sides. So we're left with 4x is equal to 5. And we divide both sides by 4 to get rid of the 4 multiplied by the x. So we're left with x is equal to 5 over 4, or 1 and a quarter. Thank you for watching. I hope now you understand how to use the fact to solve equations with unknown values in the index. Remember to like, share, and subscribe. Have a great day.